factoring. And before we actually start too much into factoring, we are going to talk about, before we start factoring with letters, we're going to start factoring with numbers. So I want you to remember prime factorization. Prime factorization is when you get something down to its prime numbers. Remember, prime numbers can only be divided by 1 and themselves. So hopefully this is a reminder, kind of, looks like a tree. And I'm just going to pick two numbers I know, divide into 60, 6 and 10. These both are even, so I know they can divide more. 6 is 2 and 3, and 10 is 2 and 5. And when I look at these, all of these are prime numbers. So the prime factorization of 60 is this, 2, 3, 2, 5, okay? 19 is a prime number. So there is no prime factorization. It is just 19. 33, so an easy one, is 3 and 11. Both of those are prime numbers, so that would be your prime factorization. So remember, factoring is kind of coming up with those most basic factors. So we're going to talk a lot about the GCF, and if you need to pause, you can go ahead and pause and write this down. The greatest common factor of 2 or more integers is the greatest factor that is common to each of the integers. A new word that you probably haven't heard is relatively prime. And that's when the GCF of two numbers is 1, like they have nothing else. So they're not, neither one is prime, but they have nothing in common. That's called relatively prime. So make sure you pause this and write down these vocab words. So I kind of have some already started. You might want a calculator. And when when I'm thinking about this, like these both end in 5. So I'm thinking, okay, I can start with 5. So 315, for example, divided by 5 is 63. So I've got 5, oops, I need my, so 5 times 63. And 63 I know is 9 times 5. And then one more time, I know 9 is 3 times 3. So I have 5 times 5 times 3 times 3. And how can you check your work? I just multiplied it. 315 divided 63. 63 is not 9 and 5, so I should stop there. And I checked my multiplying and found out I was wrong. 9 and 7 might work better. And I'm still going to factor 9 into 3 and 3. And this would be my prime factorization of 315 once I get it right. I'm going to do the same for 135. I'm going to start by dividing by 5 and get 27. And then does 27 have anything? 27 is 9 and 3. And those are all supposed to be multiply symbols. 9 is 3 and 3, so I have 5 times 3 times 3 times 3. And again, you could always multiply this in your calculator to make sure you're right. Now to find the GCF, and you'll kind of see here, I have both of these factorizations stacked on top of each other. I'm going to pull this away. And to find the GFC, I circle the ones that are in common. Okay, so they each had 2 3s and a 5, and you can see that up here too. They had a 5, a 3, a 3, and a 3, and a 3. Okay, so what is the GCF? Well, 5 times 3 times 3 is your GCF. Move both of these. You get 45. Or 5 times 9, 5 times 3 times 3. So breaking things down into their most basic factors really helps you come up with the GCF. So what happens when we have letters? Okay, so I'm going to do 36 x cubed y. I'm going to do that up here. 36 is 6 times 6, x cubed y. 6 is 2 times 3, the other 6. And x cubed is x times x times x times y. And maybe in pink here, I'll do 56. 56 is an even number. If you notice it's even, start with 2. It's 2 times 28. 28 is 2 times 14. 2 times, and 14 is 2 times 7. And then I need to have my x and y, so I've got 1x and then 2 y's. Write them all out. Under this first red box, I have them listed and stacked on top of each other. My prime factorization. Do that. Okay. And then I'm circling what they have in common. And what they have in common, I don't multiply, like I'm not multiplying 2 times 2 times 2 times 2 times x times y times y. Multiply what you circle once. So like I multiplied a set of 2's, I'm going to multiply 2. And I multiplied another set of 2's, so 2. And I multiplied a set of x's and a set of y's. And you should get 4xy as your GCF. So GCF is really the distributive property in reverse. And so that's why I left this slide here. The expression 10x squared 4x cubed is a result of any of these. But the thing I want you to realize is that finding the GCF gives you this one. Okay, so if I asked you to find the prime factorization of this one and this one, oops, 4 is 2 times 2. What I would circle is a 2 and 2 x's, a 2 and 2 x's. So that's where that 2x squared comes from the GCF. And so when I factor out a GCF from 10x squared, what I have is what's left. When I take 2x squared out of this, I am left with 5. And my plus sign stays here. And when I take 2x squared out of 4x cubed, I am left with 2 and x. So it's like dividing. And how do you check your work? You check your work by redistributing. I have 10x squared plus 4x cubed. Did I get what I started with? Yes. So the point of removing a GCF is what this whole start of this thing factoring is, breaking something into its factor. And the GCF is where you start to fully factor something out. So your homework today will be a lot like this. I would give you 10x squared plus 4x. You give me this. Sometimes it'll just ask for the GCF and then you just give it.